Similar figure unit. Here we're going to talk about ratios, proportions, scale factor, how to find if triangles are similar, polygons are similar, and the properties of similarity. Here we have an essential understanding question where we can write a ratio. Remember that a ratio is just a fraction. So there's three ways to write it. You have A over B, A colon B, and A to B. So 3 to 4 is the same as 3 colon 4 or 3 to 4. Let's put it to use. Here we want to find the ratio of the bonsai to the senator. So when you're setting up ratios, you want to have same units. So it could be feet and feet, inches over inches, or you can convert all to the same units. So first we need to know we have the Missouri picture over here on the left, and that is the senator. So here we go. We have 118 feet, which we want to turn into inches. So we're going to multiply this by 12. So we have 118 feet times it by 12, and we get 1416. So they want to know the ratio of the height of the bonsai to the senator. So the senator is 1416 inches over the 15, which equals 472 over 5. Remember, a ratio is not going to be a decimal, it's going to be a fraction. So I actually did this one was the center to the bonsai. I want to reverse it, so it's 15 over 1416. Which is just basically saying it's 5 over 472. And remember, this is in inches. So here's another example of ratios. It's 1 to 4, therefore it's 1/4. So we know that supplementary means they're equal to 180. So we have 1x plus 4x equals 180. So here it's simple algebra. 180 divided by 5 gives us 36. So if x is 36, 4x is 144, and if you add them up, you indeed get 180 degrees. Here you also have extended ratios where you can go A to B, B to C, and A to C. So it's basically saying A to B is the same thing as A to C as B to C. It's all the same. So they give us three sides in a triangle where the extended ratio is 3, 5, 6. So it's 3, 5, and 6. And perimeter is the distance around, so we add them all up, set it equal to 98. So we have 8x plus 6 is 14. X equals 98. X equals divided by 14. So it's 98 divided by 14 is 7. Now you're not done because you got to replug it in. So 3x is going to be 21. 5x 35. 6x 6 times 7 is 42. And when you add them all up, you get 98. So here's an essential understanding. If two ratios are equivalent, you can write the equation stating that the ratios are equal. Here you're going to talk about proportion. A proportion is when two ratios are set equal to each other or two fractions set equal to each other. You have your means and extremes. Your extremes are on the outside, your means are on the inside. And here you do your cross product. With your proportions, in other words, you have two ratios set equal to each other, you have your three properties. You have property 1, which is flipping, property 2, which is a switch, and property 3, which is just adding your denominator to the numerator. So here are some examples. So what's the solution? Solution, solve. So it's 9 times 14 equals 2a. Divide by 2, divide by 2. So it's going to be 9 times 7, which is 63. We can check this. 9 over 2 equals 63 over 14. Reduce our fraction. 63 over 14 does indeed reduce to 9 over 2. So that's true. Next, we're going to do another cross product. So if you have a fraction equal to a fraction, cross multiply. You should be familiar with this in Algebra 1. So you have 3 times m plus 1 equals 15m. Remember, it's distribute, which means multiply. So it's 3m plus 3 equals 15m. And we want to get rid of the 3, so we have 3 equals 12m, divide by 12, divide by 12, and we have m equals 1/4. Yes, you can have a fraction in the denominator. You can also check it, and it will be true. If you have any questions, send me an email. This is just a quick overview on Introduction to Proportions and Ratios.